We're now going to look at Indices Rule 3, and this rule applies when you have an indice in brackets and then there's another power outside brackets. So in other words, you've got an inside power and an outside power. And what you do is you multiply the two powers together. So a to the power of m and then all to the power of n is equal to a to the power of m multiplied by n. Okay, so let's apply Rule 3 in the following examples. So part A says simplify 2 to the power of 3 in brackets and then all of that is to the power of 4. Now remember, simplify means you leave powers in your answer. So part A, we've got an inside power and an outside power. So the rule is we multiply the powers together. So that's going to give us 2 to the power of 3 multiplied by 4. And then that's going to give us 2 to the power of 12. And that's our answer. So 2 to the power of 3, all to the power of 4, we multiply the powers. So our answer is 2 to the power of 12. And keep powers in your answer because that's what simplifying means. Okay, part B. We have an indice with a base of x and then it's got a power of 4 and then there's an outside power of 5. So when there's an inside power and an outside power, we multiply the powers. So that's going to give us x to the power of 4 multiplied by 5. In other words, that's going to give us x to the power of 20. Okay. Part C. We have a complicated looking term inside brackets and then there's an outer power of 2. So all of the inner powers have to be multiplied by this outer power. But you'll notice that the 4 doesn't appear to have a power. If you see any letter or number with no visible power, you can insert a 1. So what I'm going to do is I'm going to put a 1 up high immediately after the 4. Because if 4 has no visible power, then its power is just 1. So any number or letter that has no visible power, its power is 1. So you can insert a little 1 in there. So make sure all the different pieces have powers inside brackets. So the number has a power, the x has a power, the y has a power. So we're going to multiply all of these inside powers by the outside power of 2. So we're going to get 4 to the power of 1 multiplied by 2. And then after the 4, we're going to have x. And then we multiply the power of x by the outside power. So that's x to the power of 3 multiplied by 2. And then the same with y. So put our y down and we're going to multiply the inside power of y by the outside power. So that's 5 multiplied by 2. So if we put it all together, we're going to have 4 to the power of 2. And then that's being multiplied by x to the power of 6. And then that's being multiplied by y to the power of 10. Now, because the x and the y have powers, you can actually go ahead and work out 4 to the power of 2. Now, let's be clear here. In part A, we didn't work out 2 to the power of 12. It said simplify. That means there has to be powers in your answer. So if we had worked out 2 to the power of 12, there wouldn't be a power in our answer. So that's why we left it as 2 to the power of 12. But when we get to part C, there is a number with a power, but then there's other powers in the answer as well. So you can now go ahead and work out 4 to the power of 2. Remember, the power tells you how many bases are being multiplied. So 4 to the power of 2 means 4 multiplied by 4. There's 2 4s, 2 bases of 4 being multiplied. So do that, and that's going to give you 16. And then copy everything else down. So we've got 16x to the power of 6, y to the power of 10. And that's our answer for part C. Okay, part D then. Part D is asking us to work out 4x squared y cubed all to the power of 3, and that's all divided by xy squared. So again, what we're going to do then is look for any number here inside brackets, okay, that doesn't have a visible power, and insert a power of 1. So that's the same as 4 to the power of 1. We're now going to multiply all the inside powers by the outside power. So on our numerator here, we're going to have 4 to the power of 1 multiplied by 3. And then we're going to have our base x. And then the power of x is being multiplied by 3. So 2 multiplied by 3. And then we're going to have our base y. And the power of y is going to be multiplied by the outer power. So 3 multiplied by 3. Okay, and that is all over xy squared. Okay, let's tidy up the numerator. So we've got 4 to the power of 3. And then we have x to the power of 6. And then we have y to the power of 9. And that's all over xy squared. Now, we're going to rewrite the fraction as a division. So we're going to write 4 cubed x to the power of 6, y to the power of 9, divided by xy squared. Think about it. We've got our numerator divided by our denominator. So I'm now writing the fraction itself as a division. So now it's much easier to divide the bases of x and divide the bases of y. So we've got 4 cubed here. So what I'm going to do is actually work out what 4 cubed is, because there's other powers already in the question. So 4 cubed means there's 3 4s being multiplied, 4 by 4 by 4. So 4 4s are 16 times 4 is going to give us 64. Okay, so we've got 64. Now, we're going to divide the bases with x. So we're going to do x to the power of 6 divided by x. Now again, if you see a number or a letter with no visible power, you can insert a 1. Make its power 1. Okay, x to the power 1 means there's just a single x, 1x there. So we're going to divide the x's. So we've got x to the power of 6 divided by x to the power 1. So when you divide two indices with the same base, you subtract their powers. So that's going to be x to the power of 6 minus 1. And then we're going to divide the indices with base y. So we've got y to the power of 9 divided by y to the power of 2. So again, you subtract the powers. That's y to the power of 9 subtract 2. So tidy it up. We're going to have 64 x to the power of 5 y to the power of 7. And that's our final answer. That's it, fully simplified.